The objective of this lesson is to solve problems using the order of operations. In previous lessons, students have learned that multiplication can be thought of as repeated addition, and division can be thought of as repeated subtraction. Today, the students will use that knowledge to understand why multiplication and division are completed first in the order of operations. A common misconception to note is that a mnemonic device such as PEMDAS, which is also known as Please Excuse My Dear Aunt Sally, can lead students to believe that multiplication must always be done before division, and addition must always be done before subtraction. Multiplication and division come before addition and subtraction simultaneously from left to right. Multiplication equations and expressions can be written many different ways. On the left side of this chart, each expression reads 3 times 10. On the right side of the chart, each expression reads 3 times b. Let's start with our first problem. Maya and Jenny solved the following equation and each got a different answer. 7 plus 5 times 6 equals s. Maya said that s equals 72. Jenny said that s equals 37. Who is correct and why? This problem requires the use of the order of operations. Let's think of this problem in terms of eggs in order to put the expression into context. There are 7 eggs plus 5 rows of 6 eggs. How many eggs are there? There are 2 ways to solve this particular problem. The first way is by using repeated addition. 7 plus 6 plus 6 plus 6 plus 6 plus 6 equals 37. 6 eggs in each row were added 5 times and then added to the extra 7 eggs. The second way to solve would be to think 7 eggs plus 5 rows of 6 eggs equals 37 eggs. Remember, multiplication is repeated addition and therefore must be completed first before addition. Looking back at the initial problem, Jenny solved the problem correctly because she completed the multiplication first before adding. Order does matter. Let's try another problem. Charlie had $20. He and a friend went to lunch and evenly split the $14 bill. How much money does Charlie have left? Charlie started with $20, then subtracted his portion of the bill, which was half of 14, or 14 divided by 2. The division must be done first, because 14 divided by 2 represents how much of the bill Charlie needs to pay. Division is repeated subtraction, and therefore comes before subtraction. Let's solve. First, find the total bill of $14 divided by the 2 friends equals $7 each. Now take the $7 that Charlie has to pay away from the $20 he has for a difference of $13. Charlie has $13 left. If the order of operations was ignored in this situation, the problem would state that Charlie had $20 and $14 was subtracted for a difference of 6. The $6 left would then be divided between the 2 friends for $3 left. This does not represent the problem at all. This is why completing the division before the subtraction is vital. Let's look at one more problem. A group of students in Miss Bateman's class solved the following equation, and each got a different answer. 24 plus 16 divided by 4 times 2 minus 1 equals k. Ryan said that k equals 151. Michael said that k equals 31. Soraya said that k equals 10. Who is correct? Why? The order of operations state that multiplication and division are done simultaneously from left to right before addition and subtraction are done, also simultaneously from left to right. To solve this problem, the first operation to be done is multiplication and division. Division comes first when moving from left to right, so divide 16 divided by 4 equals 4. Our equation now reads 24 plus 4 times 2 minus 1 equals k. Multiplication will be the next operation to solve. 4 times 2 equals 8. Our equation now reads 24 plus 8 minus 1 equals k. The next operation to be done are addition and subtraction from left to right. 24 plus 8 equals 32. Our equation now reads 32 minus 1 equals k. Subtract the 1 from 32. 31 equals k. Michael was correct because he followed the order of operations. The objective of this lesson was to solve problems using the order of operations. and we met this objective by solving multiple problems where addition, subtraction, division, and multiplication were presented in a single equation. By looking at the division as repeated subtraction and multiplication as repeated addition, the importance of completing these operations before addition and subtraction was emphasized.